Okay. So this one, this is the last thing that we're learning in this chapter, right? The last new thing. And it's another thing that we have to do with the calculator in class because you don't get a calculator to take home. Because it's more important to give kids iPads across Hampton City schools, which is not going to help. Well, it's about to get them. What's that? Yeah. Okay. So this is the thing that we're going to practice in class today. You won't get a chance to practice at home because you don't have, unless you got a graph and calculator at home. This is the one SOL that addresses it, and what it says is we should be able to identify the zeros graphically. And we kind of already know how to do this in most cases, but not every case. So we just need to learn how to do it for every case. Now let's see what I got left. I just like to do this one anyways, but I mean, here's a cubic. We just did one that was a cubic over there. And just the idea, remember when we had this as a cubic, if there's 3 complex, there could be 0 or 2 imaginary. There had to be at least one real solution, right? Which means one x-intercept, because just the shape of this graph, you know, if it's going to have end behavior, which is down on the left and up on the right, somewhere in the middle there, it's got to cross the x-axis. That's why you have to have one, right? But you could have 1, you could have 3, or you could have 1. Those are the possible situations for a cubic polynomial. Yes? Like that? Come up here and show me. It can't be straight up and down like that. No. I mean, if what I think you're describing, you know, is a piece of this graph which is like straight up and down, it wouldn't be a function anymore. It would fail a vertical line test, right? So we wouldn't expect that. I mean, how many real solutions is there? Yeah, remember, this is an important thing we're supposed to recognize. When you see the graph touch the x-axis and then go back in the same direction, that's an indication that the factor is squared or to the 4th power or some even power. Most of the time, it's squared, right? So that would be, we could tell by the shape of the graph, that's a cubic. And that's 2, and that's 1. There's your 3. There's no more, right? And there's no imaginaries, right? Same thing goes with a quartic, right? We recognize the shape of the graph as a quartic. How many zeros do you see on that? You know, you can definitely see the 4, right? It could be that there's actually 2 or 4. There could be, you know, some odd combination of, let's say I did it like that. It would look like there's just 1, but that 1 would be repeated, right? Or there could be 0. It might stay all one side of the x-axis. It never crosses, right? What we're trying to find today are the real solutions. That's all we can do with the calculator, because the calculator is showing us x-intercepts, and everything on the x-axis is a real number. So let's say and this is a calculator thing. You should have your calculator, and you should be playing along here, okay? If you don't, I'm not helping somebody who's not trying, okay? And you will be asked to do this on the test. I'm not answering questions during the test. If you haven't figured it out by then, sorry. Right. Go ahead and, if you put that one in the calculator, you're going to see the graph that I've got there on the screen. And you see it's a quartic. So we kind of know what the shape ought to look like. Does it look kind of like a quartic? I mean, we're missing some of the down here, but yeah, it looks pretty close. We could expect that it has how many complex zeros? It has 4 complex zeros. How many do I see on the graph? Well, there's 1, 2, and 3. But what do you know about? What do you know about that right there? That represents 2, right? So there's our 4. Now, you can go to the table of values and confirm that it looks like it's at -2 and 2 and 6, right? How do you tell that in the calculator? Go to second graph, right? I don't think I have this one in there yet. But you go to second graph for the table. What's wrong? I don't have a function up there. Let's say I put an X. You know, wherever you see a Y equals 0, then the X value is the 0. So does this confirm that it's -2 and 2 and 6? Are all those zeros in your table? When you go to the table of values, do you show Y equals 0 at X equals 2, -2, X equals 2, and X equals 6? Yeah. Natalie? Yeah? Okay. So you confirm that, right? A lot of times solving by graphing can be that easy. Just look it up in the table of values. Most of the time in your calculator is set in the table, and understand the table set is above the window, right? And it's set so that it's showing you every whole number 1. Actually, we should say integers because it could be plus or minus. So that's why when you go to this table, it doesn't have like 0 and 0.5 and 1 and 1.5 because it's set to give you every 1, right? You can set it differently if you want. But if you have it set to, put the pass up here. If you have it set to every 1, then you could find the integer values for zeros only. All right, try this one, which is a cubic, which should have 3 zeros. And I'm looking at the graph, and it does. So go ahead and try that, see what you see. It's important to have this one in your calculator. Yeah. Right arrow. That? We're dealing with this one now. I mean, if you don't have any calculator. Yeah. Try Zoom 6. If you get a lot of dollars, just clear the number. Second plus 7, 1, 2. And do it again. It'll work. You get it? So your graph, if you want to get back to the better part of the graph, just go Zoom 6 for standard. There you go. Right? Listen up. When you look at your graph, if your graph is not centered on the origin with about that spacing there, then you want to go to your calculator and go Zoom 6 for standard. It makes it look like that. Okay? If yours doesn't look like that, then do Zoom 6 to make it look like that. Okay, now, if you go to the table of values for that one, it looks like the zeros are at -1 and 1 and 4. But when you go to the table of values, none of those has Y equals 0. Right? So the zeros are not at the integer values. That's why we need to know how to find the values when they're not right at the integer values. Okay. So let's see. We're gonna learn the calculator procedure for doing that. Now there are 3 zeros there, right? Now if you look in this table of values, you can kind of see where which X values the zeros are in between, right? Because like look at this one here, which it looks like it's around -1. Well, look at it in between -2, X equals -2, and X equals -1. The Y values go from -17 to +1. So clearly across the X-axis, somewhere in between, X is -2 and X is -1. Right? That's actually a theorem called the intermediate value theorem. Right? There's no way for that graph to have gone from Y equals -17 to Y equals 1 without having every value in between. And 0 is in between. So there's 1, 0, right? Oops. Right, there's 1, 0 there. What are two other x values there? You could see the y changes sign. Okay, so it goes from 1 to -5 in between which two x values? 1 and 2. 1 and 2. So there's another 0 because it's changing sign. Okay, and now there's one more interval that we can see there's an x value, or there's a 0. Yeah, look, it goes from -7 to +1, so it must have crossed the x-axis in the middle, so that it would be between 3 and 4. As far as that, now we're going to figure out how do we find exactly where those are. Okay. Okay. Now we are going to be doing this. I wonder if I still have that in there. I don't have that in there. I'm going to put this in just to have it so I can show you. No, I'm not. The trace key, if you try to use the trace key, it will go along the graph. It's not going to find your zeros. It may get close to a 0, but it's not going to find the zeros. If you already think you know how to find zeros by just using the trace key and letting it get close, that is not going to be good enough, right? That is not good enough. You have to do what we're doing here today, right? And here's what we're doing today, right? First, you all should have already put your function at the y equals. That's how you got the graph we looked at on the last slide. Now, look above the trace key. It says calc, right? Not the same calc that we did when we were doing stat calc and making our models. But this one, you have to hit the second to access. So go second trace. And then you're going to see this menu right here. And the second option, the number 2, that's 0. We're trying to find the 0. So you go second trace 2. And what do you see? It says left bound, right? You see this left bound right there. Now we're going to try to find our 3 zeros. You got to do it one at a time. So I'm going to start on the leftmost 0. That's this one right here. When it asks for a left bound, it is asking for an x value which is to the left of the 0 that you see. I mean, you don't know exactly where it is. But, you know, you could put in an x value, anything over here if you wanted to. I mean, it would be fine. What I'm doing on these slides right here is I'm just using these x values that we identified where it had to be in between -2 and -1. So let's use -2 to be our left bound. Okay, so you enter the -2 and then you hit enter. Right, so if we're going to use left bound -2, go ahead and enter the -2, hit enter, and then what do you see? Josh, you doing this? You're staring off into space. So you're just going to x to the 3rd power. Right arrow out of that. Okay? You can't sit here helplessly. Okay? There it is. X to the 3rd minus 4x squared minus x plus 5. You know, there's a lot of, listen up, there's a lot of going around checking homework, people say, I don't understand this, I don't understand this. Well, what are you doing about it? I mean, what are you doing about it? You're going to have a test in like 2 classes from now. I'm here every day. Every day. You can't just sit there when you know you don't understand something and just let the truck run you over, okay? Do something about it. Don't just sit there helplessly. You got to learn to be a little more, you know, persevere a little bit more than that. This is not an easy subject. You're going to have to probably work harder than you're used to in some of these other classes, just hand you worksheets all day, right? Yes. I told you to put in -2, okay? Listen, do exactly what I'm telling you to do, okay? Exactly. I just told you, put in -2 and hit enter for the left bound. If you're going off on your own, then it's at your own risk. I'll show you ways that you can do this that are not exactly like using these exact values. That's fine. But right now I'm trying to get everybody to do it one way so we can all understand that. And then we'll look for the variations of it. Right? So you should have done the -2 for the left bound, you hit enter, and it should have looked like that. Now it says right bound. Okay, now it wants an x value which is to the right of the 0 that we're looking for, but not so far to the right that it's to the right of other zeros. So really, you would have to be like somewhere in that small interval right there. Well, you know, that's why I just use the -1. We know it's in between -2 and -1. Put in -1, enter for the right bound. What does it say when you do that? Yes, right? And what it's saying for the guesses, these triangles at the top, those are your left bound and your right bound. It's saying, do you want the calculator to calculate in between those two? And you always say yes. You just hit enter. At that point, just hit enter. See what you see. Right? The cursor should have gone right to the 0. And then in the bottom, it's telling you the 0 is -1.093763. Notice the value of y. Right? That's by definition what a 0 is. It's the value of x when y equals 0. There you go. Okay, that's just one 0. Now we got to find the others. Okay, let's find the one in the middle. And again, remember when we went through the table of values here, we said the one in the middle is in between x equals 1 and x equals 2. So let's use those for our left bound and right bound. Right, so for the left bound, you're going to go second trace 2 to get back to the same left bound screen. Then hit 1, enter. Then what? It says right bound. What are you going to use for that? Use the 2, because we know that's to the right, but not too far to the right. Enter. Right? And now it's asking you to guess again. And go ahead and guess. Did you get that, Mark? 1 point. It should be the cursor looks like it's right there on the 0. Y equals 0. There's your 0. This whole left bound, right bound, the calculator uses that for more than just this one thing. But they use it for finding maximums and minimums too, which we haven't done that in this class yet. But I mean, you just have to get used to the way they ask for this kind of information. Okay, so we still have to find the last one. So let's do it. I'm going to do that in the same way. Right? I'm looking for this 0. So again, go second trace 2. And then since it's in between 3 and 4, let's use 3 as the left bound, 4 as the right bound. And what do you get for a 0? 3.931, right? Now, this is how, I mean, most of the time, we don't use the table of values to find our left bound and right bound. Here's your other options, but it's really going to be up to you to make sure you're not using things that don't work. Okay, you could go like this. In fact, now we're going to put this in. X to the third, x hat 3, right arrow, minus 4x squared, minus x, plus 5, graph, zoom, 6, right there. Okay. Let's say I wanted to find the one on the right. Second trace 2 for that. You know, you don't have to use just those. As long as, like, if I want to find that 0 right there, I can enter any value that's in that zone. If you could just see it with your eye and it's easy to see, then go ahead. I mean, you could put 2 or 3. It doesn't matter. As long as it's to the left, but not too far to the left of the 0 you're looking for. So I'll enter 2. And then for the right bound, you see if I'm looking for that 0, then to the right means on the number line, right of that are all these x values. You got to do an x value which is on the screen. If you go with an x value that's like way over here, you'll get an error. But let's say 8. 8 looks like it's to the right. and then you hit guess. Okay, quiet please. Let's finish up. Okay. So like I said, you can go through that process by just entering in an X value as long as you can see it's to the left of, to the right of the 0, right? But what most people do, honestly, is this. Let's say I want to find the middle one right there. They'll go second trace 2, and then they would use the arrows left and right to move to the left of and to the right of the 0. So if I can see the cursor right there, I need to get to the left of that 0 that I'm trying to find. So I hit left arrow, watch the cursor move, right? Okay, now it's on the other side. Okay, it's right there. Enter. That's my left bound. Right. For the right bound, use the right arrow and go to the right. Enter. And so there's my left bound and right bound. Yeah, I want to guess. And there it is, same value. So you have a few options for putting your left bound and right bound. The main thing is understanding what do they want by left bound and right bound. Because, like it or not, you're in Algebra 2, you're going to be doing this for years using these calculators. You got to learn how to do it. In the end, it's not a hard thing to do. Okay, so try one more. See if you can find all the real zeros for that one. How many real zeros is that going to be? Could be up to 3. Right?
Thank you for your orderly and timely response in regards to the evacuation. Today, we did receive a message regarding a bomb threat hoax. A student attempted to disrupt our school through this bomb threat hoax. These actions will not be allowed. We work collaboratively with the Kansas Police Department, school administrators, and Kansas City schools. Security is nothing was found. The Code of Virginia makes illegal communicating by any means a threat to bomb a class 5 felony. The threat to bomb also results in long-term suspension or expulsion. Our schools are safe, and our students take their learning seriously. We cannot let a few students ruin the instructional experience for all students. We need your help in keeping our schools safe while also protecting our learning environment. If you have any information in regards to these recent situations, please let us know so that we can resolve these issues. Once again, I cannot stress the seriousness of these hoaxes. We are going to exhaust our resources to identify who is behind these hoaxes so that it does not continue. Thank you, and have a great rest of your day.
Okay. So do you get a graph that looks like that? Now, looking at it there, it's pretty clear that these two are not at integer values, but that one might be. Check your table of values, right? Because you don't have to find it using that method if it actually shows up in the table of values. It's actually 5, right?
We are now code out. We are now code out.
Okay. So we found the 5 just by looking in the table of values. Now, did you find the other 2? What were they? Plus or minus 1.732, right? That's what they were. So again, if you just to follow through with the procedures, right? It goes like second trace 2. I'm going to find this one. I like to just enter the X values. So I'm going to put in -5. I'll put in 0, and then I'll guess -1.732. Okay. So with that, you can find any real 0 because real zeros are X-intercepts. You can always find the real zeros. Yeah. Again, you have to pick an X value, which is to the left of the 0. You can tell that value is in between. It looks like it's around -2. So why don't, just to be safe, pick a value that's over here. It doesn't have to be an exact number. We could all pick something a little bit different. I put in -5, right? And then for the right bound, put in a value in here. It looks like -1, 0, 1, all of those are okay. Again, or use your arrow keys. If you want to use the arrow keys, go second trace 2. Right? I'll find this one now, the middle one. So I'll go, I'm going to arrow over so I can see it. I get a comfort just knowing that it's there. There it is, right? There's the cursor. It's to the left of the 0. Enter. Use the right arrow key so that it's to the right of the 0, right? It should be on the other side of the x-axis. Right? When you get an error that says no sign change, it's because you put in 2 points on the same side of the x-axis. Okay, enter. Enter. 1.73. That's it. Okay. And that was all we're trying to get out of what we're doing today. Now, the homework is actually, I think this one is a solve by 301. That was the solve by factoring. I think they might be sum and difference of cubes. And I think this one might be just factoring, like GCF plus, what I was calling GCF plus.